Hello, guys. Um, Today I want to teach you. Um, hello, everyone. Today we're gonna be doing um, this door simulator program. So, first of all, what you need to know, you should analyze all the instruments are given here and know the type of the instruments. So on this simulator, I'm just using the Logix Pro simulator, of which is emulated. It's actually emulating the Studio Logix or Rslogix 500. Um, if you're familiar with Rslogix 500, then you can see the layout. It's almost similar. So we're going to set up on target or operation what I need us to do on this one. We actually need to open this door, then when it reaches the open limit it stops. When you press close it comes down, then when it reaches the close limit then it stops. So if you open it while it's on the way opening, you can press stop and then it will stop. So here we're given open limit and the close limit, and here it's our motor. So it's having the forward, reverse and the forward. You just need to push your motor in reverse. If you want it to open, then you press it in forward. If you want it to close. So but that one, it's not a very big concern. So there is our outputs. We're given the open light, of which should be linked with the open limit, or it should be activated when the limit is made. Then there's this one for shut. When the door is shut, it's closed. You actually activate the limit, and the limit should triggers the light. So here basically it's our controller. If you're familiar with the 1756L, this is a chase for open automation. So in most cases you can actually put the controller on the slot 0. Then on the slot 1 we normally put a communication module like Ethernet module or Profinet or any kind of communication modules. Then from slot 2 we normally put our I/O modules, talking about analog in, out, digital in, out. So but on that one I'm going to specifically make a video on it. So here let's just go and write this program for this process. So here, first of all, we need to add a RAM. Okay, so I don't know why I'm struggling to add the RAM, but anyway, let me do this. I'm going to add my first button. This is going to be my start, and then normally I will just check if this door is actually wired as a normally closed. You can see that it's a normally closed push button. So if it's normally closed, meaning our digital input card will always receive the 24 volts, and then the contact should be what, if it's we use this one, examined if closed, then it's gonna close, keep on closing, then it's like a fail safe. um, Here I'm just gonna put the output, so of which is the one that's gonna be driving the motor. So here I'm gonna actually focus on opening first, because our door, as you can see, it's illustrated above, it's actually shut, it's closed. So this one we need to give it a name. We edit the symbol, we write it's open button. So this open button, I'm not sure if my spelling is okay or it's wrong, but you can correct me if I'm wrong. So what we want in this scenario, we want the door to open, and then whilst it's actually opening, we need to indicate that our adjust lamp shows that the motor is actually running anyhow. So we're saying when we press the open, or you can call it it's running. I'm gonna use it as my running light. And then what must happen now, we goes into the interlock. We want to say, okay, since I'm running, I should either use the latch as an output, so that I'll unlatch when I press the stop, but I'm gonna make it simple for everyone to understand. So here we actually going to have start, then whilst this one it's running, whilst this one it's energized, it's gonna latch through this one here. Here it's actually our stop. This is the one that we're going to use to stop. It's gonna be my stop button. This one, remember, it's normally closed, and then as soon as we go online, the PLC is gonna detect the 24 volts, and it's gonna change the state to close. So I hope you understand why I have used this contact. So it's actually examine if closed, because we only watching at the closing signal. The contact in the field is closed. So ready, let me add my second run. So on my second run, I'm gonna say, since my running light or my output it's energized, then I can run what? I can run the motor. I can run the motor. I'm running it up. So I'm saying, okay, I'm running the motor up, and then, so this one we should just give it a name. It's up. Okay, let's just call it up. So as soon as I press open, this adjust light will show that it is a movement, and then we are now running, and then we start rolling up. So now we don't actually need our motor to go forward and reverse at the same time. We should implement some that kind of the interlock, which will actually interlock the motor or prevent the motor to run forward and reverse at the same time. Yes, so what's going to be needed, I'm going to show you right now. Let's go online and see how is our program running. So we are now online. So meaning if I press open, you see that the motor is actually running, and you can see that my stop button has actually closed, and PLC is detecting that the signal, since we have used the normally close button in the field, so it's detecting that the signal is still closed up until we open the contact. So right now the challenge is one. You see, it's gonna be running, and then the motor is gonna get damaged unless if we we stopped. So otherwise, in order for the door to auto stop, we need to introduce what, this limit. So this limit, you just need to look at the striker. You can see that the striker is adjusted in the downwards position, and if this door is going up, meaning it's gonna make the striker while it's going up. So we just see how is it wired in the field, because so they say it's normally open, not activated when the door is fully open, so else it's activated. So meaning that this switch is always activated and it's a fail safe, so it's normally open. So if it's actually normally open, so the saying that it's normally open, not activated when the door is fully open, so it's always made, it is already made. So right now we need to implement a logic that would actually, when the switch is still engaged, so you can see that when the door is actually has passed on this one, it becomes healthy. So this one, it's more like it has been made already. So we need to say if the door is open, then it's unmade. So we need to use this kind of contact that's going to be able to stop it. So if I put this one, examined if closed, I'm saying on my program that as soon as the door is actually, you see that they say not activated when the door is fully open. So right now it's not made, it's going to be running up until the door is fully open, then it's going to be activated, then it opens the contact. So this one, you can call it open limit. So now we can actually reset our simulation, and then we basically gonna go download and go online and see what is now going to happen. So sorry, download, then I go to run mode, then I open. So you see, the challenge now is that this switch, they say it's not activated when the door is fully open, else it's activated. So else it's always activated. So right now it's more like the door, it's actually activated. I mean, it's activated right now, and then when we open it, it becomes deactivated. So it only gets deactivated when we open the door. So right now, look at it, it's deactivated already. So I'm gonna use this one, examine if open, and then I download and see. So right now, it really shows that the limit has been made already. So it's gonna cut because it's a fail safe. So fail safe means in case that if we lose power on the system is not gonna run anyway. So or if we lose the power on the limit, like the 24 volts, it's lost, and then the door it's not going to open. I mean, it's going to open, then when it gets there, we don't know, remember that the fuse has been popped on this limit. So how are we going to know that the limit doesn't have a 24 volts? Otherwise we're going to bend them out. So we need to use in such a way that we use that 24 volts in here to detect within the second. So let's proceed. I'm gonna open. So as soon as this one deactivates, you see it say else, it's activated. It's true. So it's not, it's deactivated when the door is fully open. So let's see. It's gonna be deactivated when the door is fully open. Hold on. Just gotta be patient with this thing. You don't really need to rush, because when you're making a program for something, you actually using your own logic. So it's very important to, you see now it's deactivated and it has stopped. So I was still saying that if you're writing your own program, you don't need to think of other people's opinion. It's about you and your process. Understand the process first. Then you can take people's opinions when you're going through the stormy weather. But if you understand the process, you can manipulate the program anyhow. Remember, the logic is from your mind. You set it anyhow. So you can manipulate it anyway so that it suits your operation. So basically now we have managed to open the gate, and right now we need to have a rung that where we're going to move the motor in a downwards position. So now we have opened it. Let me do this. How are we going to run it in the downward position? So in the downwards position, we're going to say, okay, since the motor up has been stopped, so what is it needed now? So I'm going to say, in order for me to run the motor downwards, I'm gonna use the similar outputs. So remember guys, also I'm giving you how we write in the program. You think first. So step by step, we just go together and we do this thing. We're gonna make it work so that it suits the application. Someone might write it their own way, but even us, we just do it step by step using our common sense. So if this is motor down, what is it needed to actually drive the motor down? So we actually need to say the motor down close button. It is the one that we're going to use. So here it's another, there is another issue here. So let me do it, then we shall correct it when it's not working for us. So motor down, I'm saying the motor down, but it's not interlocked. I will say if, unless if the motor is going up, if the motor is going up, don't ever run. So you can say down, 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 down. It's not gonna work because otherwise we're gonna blow the motor. So you're gonna have to stop it, and then that's when you can move it down. So here I'm gonna say, okay, so here I'm gonna say it's down, edit symbol, it's down, so if it's down button, okay, and then what's going to happen, so we're going to have this motor running down, and then this is the down motor, this is the motor, yes. So we're moving the motor downwards, and then we're going to use the same motor output to run it down. And then also this side, I'm going to say as long as the motor is not going down, should be going up. So according to me, okay, let me do this, let me take this one and put it here. So running up, this running, let's be practical, and then this actually this around, let me just cut it. So this side we will be saying this is the stop, let's copy, then we're going to put it here, we paste. So this is going to be our stop, and this is our down motor, this is the up motor, yes. So right now we're only going to stop it when this limit has been made, but you can see that they activated when the door is fully closed. So it's activated when the door is fully closed. So right now here we're going to say, since it's going to be activated when the door is closed, we open the position so that it's stopped. So we close limit, edit symbol, it's going to be there, close limit. So right now I'm going to do this, I download, and then I run. Let's see. So let me first reset the simulation. Okay. So let me reset the simulation, and I can say we download, then we run, put it on run mode. So when I say open, let's see what's happening. Open. Okay, so now my problem is that, remember, I have deleted that RAM which we used this output as a latching. So right now it's our door, it's not latching, because you see, so you can see that the power is actually flowing from here to the motor, but there's nothing holding it. So we need to have the hold on contact. So look at the close, it's closing up until the limit has been made. So right now we need this contact, copy, we need this contact, paste. So it's a motor app, so I'm latching with this motor, and I download, then put it on run, then say open. So you see now, since the motor is running, it's now latching with this, and the sprint return button has been released. So we actually waiting for the motor to open. Anyway, then you see, if you can, whilst it's opening up, you can say close. Nothing's gonna happen. So what's gonna happen, you have to press the stop, then it stop, you can close it. So, or you press stop, you say open. So you can't use the other buttons because of the interlocks. So in case of the emergency, you press the stop. So when the limit has been made, the door will actually stop moving. It's no longer rolling, we are safe. So can we close? See, now it's closing, and then as soon as our limit is made, then it's gonna stop rolling down. So we actually prevent the motor from overloads and the burning. Okay, so we are safe. Right now we are left with the indications. So these indications should go hand in hand with what, with the operation as it is. So we say that if the motor is going down, it's going up, or it's going down. I'm gonna be showing that the first symbol that I've used, that copy, that AJR paste. So we're going to say if the motor is either going up or copy, it's either going up or down, paste. If the motor is either going up or down, what are we going to do? We're going to say, show the AJR light to show that it's moving. So as soon as it stopped, then this light will go off. And again, as soon as it's open, we need to indicate that it's open. Then as soon as it's closed, we need to indicate also. So how are we gonna do it? We're just gonna say, okay, since I'm having my limit and it's always active, so it's not activated when the door is fully open. So right now it's active. So we're going to say on this one, it's not active when the door is fully open. So let me see. We say it's not activated, it's false. There's no power, there's no 24 volts to the card. So meaning I should use this one when it's fully open. Yes, we're right. So I'm gonna use this limit, close limit. It's actually, this limit is an open limit. Let's read. We're saying not activating when the door is fully open. So when it's fully open, it's not going to be activated. So then it gets back to this example, if closed. So we say it's open, and then it's an open light, open light. And then on this one, when the door is activated, when the door is fully closed. So if it's fully closed, where is the limit? This one, if it's fully closed, this one will close, and then we're going to have our output energized. So it's now shut. It's edit symbol. It's a closed light. Okay, so it's more like the indicators. So can I download the program, and then you see now it's currently closed. So it's showing that the indicator is shut. Then when we open, what matters here, it's the interlock. So if it's opening whilst it's busy opening, you cannot close it. We are safe. Why? Because you press here, the motor is running up, it has broke the circuit. We are more than safe. Then whilst it's busy opening, we show that the AJR lamp is on. So I don't know what is that AJR mean, but me, I'm just gonna assume that it's adjust or something to do with the movement of the motor. It's like a run feedback. So right now it's open, and this limit has been made. We indicating that it's open. So I'm gonna close it. So I'm actually now going to close, and then the garage door, when the limit has been made, the close light should come on, and also whilst it's on the way down, if you say open open open, it won't open because of what? The motor down interlock is actually stopping, preventing the motor to go the other way around. Imagine if the motor is turning this direction, all of a sudden you reverse it without stopping it first, it will burn. So hopefully you understand and you enjoy the practical application for this process. Um, just stay connected and keep more. I'll keep you more with the coming videos. So subscribe and like on my channel. I thank